let me pull a chair for you. I'll go to this side. Jill tells me, my CMO, Jill tells me that my left side's better side. I guess I look fatter from the right side. I don't know.
You look handsome.
Thank you. I love it. So, Chris, great to see you. You flew all the way from London.
Your dollar token, thank you.
So, register. How many people follow Chris Mellor? Please raise your hand. Come on, energy a little bit. Almost all the room.
Thank you very much.
And this is only half of the room, right? So, Chris, you listened to a bunch of people here, a bunch of vendors. You were all VMworld here for the full week. What are your observations?
Can I speak for a while?
Absolutely, that's yours. Stage is yours.
If I speak too long, stand up and tell me to, time out. A few years ago, life in the storage business was really simple. There were 6 mainstream vendors. They held out dual storage, dual control, and monolithic storage arrays. And whenever competition came along, they just swallowed them. Compellent, Equal Logic, left-hand networks, 3PAR. They all posed threats to the mainstream storage vendors, and they're all gobbled up. There was other stuff that gobbled up. There were Data Domain and Diligent, people like that. But I'm talking about just the broad mass of the storage array industry. Now, I can't see it happening again. There are so many things going on at this moment because lots and lots of people around 1995, 2000 looked at storage arrays and said, you're the problem. You're not the solution anymore. You're the problem, and we're going to fix it. And I'm looking at the storage industry, and I was trying to explain to my brother yesterday, on Sunday rather, how this is coming about. And he said it's like a dog walker. He said, can I get up and walk around a bit? Is that all right?
Absolutely, please. Stage is yours.
You've seen dog walkers in the street with about 30 dogs on a leash. Well, the storage industry is like a dog walker with about 100 dogs on a leash. And there are puppies, there are sleek dogs, there are old ones, there are slow, fat ones. They're all breeds.
Irish Jack Russells.
Yeah, they're barking.
Yeah.
They're looking at the things to smell on. They're trying to screw each other too sometimes. This is the storage suppliers. And you look at what's going on with this dog walker, and the dogs are going all over the place. Some are going forwards, some are going backwards, some are going sideways, some are saying, I'm not moving. And so you think to yourself, well, what's the storage industry doing? And if you look at it at one moment, it's all a hurricane of activity. It's a jungle out there. But over time, the storage industry, you think, is going forward somewhere. And that's what I think my job is trying to be, trying to work out where the storage industry is going. And the thing that I perceive is that there's a kind of a San Andreas fault running up and down the IT industry between servers on the one hand and storage arrays on the other. And the gap is the data access latency gap. Good Lord. I'll put this in a pocket.
I don't know who made that system. More than like a
Look,
legacy.
Shame it came from his guy. Incidentally, where's his brother? Salt.
Coming out soon. That's a surprise.
This gap, this San Andreas fault, there's rumbles because it's as if there are volcanoes in the bottom of it. And the lava's welling up and pushing the server side of the plate away from the storage side of the plate. And the thing is, there's not just one rumble, there are lots of them. And all these various people looked at the storage arrays and came up with their answers to the problem. So the converged and the hyper-converged people said, you're difficult to get. People have got to buy servers, they've got to buy networking, they've got to get storage. And the storage arrays are hard and complex. Wouldn't it be much better if you just put the whole thing together in a single SKU, bought it, ran it, and managed it as a simple thing? The public cloud people said, no. Just shift the mess out completely. Save a whole load of CapEx, turn it into OpEx, and save humongous amounts of money by moving all your storage to Google, Azure, Amazon, whoever. The server flash people said, the problem with data access latency is you've got the wrong media. You know you've got to do this, move to flash, get your data in a flash, and go to the all-flash data center. The hybrid array people said something different. They said storage arrays have got old and clunky storage software. It's riddled with problems, it's held back by RAID, and it's slow and it's complex and it's horrible, clunky. Use our software instead. It's newer, it's lean and it's mean, it uses flash and it uses disk drives better, and we're cheaper and faster and simpler to operate. Nutanix, SimpliVity, people like that. The server flash people said, rubbish. You should put the flash in the server. Then you have storage close to compute, you get lightning fast access, you do away with network latency and disk array latency at exactly the same time. There are lots and lots of these people all saying you've got to fix the storage array problem. And it seems to me that they're all focusing on this data access latency gap. And is it okay to carry on?
Please keep going. I'm enjoying it.
Keep going. I want to look at two particular parts of this. There's the hardware side, the server edge of the gap, so to speak, and then software-defined storage. And I think these are the two hottest areas in the storage industry at the moment. So, the future of the primary data networked array is going to be written in 3D NAND Inc. and NVMe fabric networking. The future of storage in the server is going to be written in 3D flash memory, cross-point memory, NVMe, and storage memory. And the third thing I'm seeing is that the boundary between servers and storage is blurring like crazy. We can point to Supermicro, they're servers. We can point to SanDisk, that's storage. They're coming together. We're going to see machines in the middle at the end, which will have both characteristics. And why do I think this? You walk around the show, VMworld today, you'll have seen lots and lots of stuff. There's the Flash Memory Summit that was recent as well. And we saw there Samsung coming out with 3D TLC flash memory. Gigantic increase in density. The 3D, you have layers, 32, 48 layers of flash gels. 3D, you've got 3 bits per cell instead of 2 bits per cell. It gets better. There is QLC, quad-level cell memory coming. Now, at the moment, if you have TLC on an ordinary planar chip, its endurance is very, very low. It's not enterprise class. You put it on a 3D chip, you've got so much real estate on the chip, you can use larger cells, more electrons, longer life. QLC at the moment, if you did that on a planar chip, you get about 2 minutes life out of it, writing to it. But again, do it on 3D, large lithography, the thing works. Samsung came out with a 16 terabyte SSD. Toshiba yesterday talked about having, by 2018, using 3D TLC, 128 terabyte SSD. I mean, these are just monstrous amounts of storage. That's very, very fast. Cross-point memory. The odd thing that's happening, there's this spectrum, isn't there, of data access speed. And there's RAM and there's NAND. There's this little gap between the two. And what Crosspoint's done is vastly widen that gap. 1,000 times faster than NAND. Not much more to make, well, less expensive than DRAM. And it's real. When Micron and Intel first announced it, we all thought, what the heck is going on here? Where did this come from? We've all known about phase change memory for a long time and other forms of resistant RAM. I mean, how long has HB been beefing on about memristors? Now, memristors is one of those things that's always going to be in 2 years' time. But Crosspoint looks real. And I've heard from people who are talking to Dell, to HP, and to others whose servers are going to be using this darn stuff. Diablo Technologies, ultra DIMMs. You put flash on a memory DIMM socket. You expand the usable address space inside a server. You have to share the memory space between DRAM and between flash, but you get vastly more logical address space inside that server than you can with DRAM on its own because it's more affordable. VMware's vSAN 6.1 supports this. Specifically, it supports the ultra-DIMM technology coming out of SanDisk. That really made my mind go working. So we suddenly got DRAM, crosspoint, flash DIMM, flash. We've got 4 tiers of solid-state memory. Tejil bring out an array which has 2 tiers of flash inside it. This is one of the hybrid array startups, flash, disk, tier between the two. Now they can do that between 2 levels of flash. And the capacity in the capacity tier of flash is going to be dozens, tens of terabytes. The thing I think from that is that the hybrid array vendors, with their tiering of data between flash and disk, are better placed to cope with this than the all-flash array vendors. Pure has no data moving software. Tejil, Nimble, Tintri, they do. That's what they designed their systems to do in the first place. So all of a sudden, if this is important, Pure, Caminario, Violin, SolidFire, they're at a distinct disadvantage. Well, Pure's at a disadvantage anyway because it believes in fantasy. Right? Did we all enjoy the Gartner numbers? It was wonderful. The server storage area is going to embrace NVMe fabrics. So inside a server, you have this I'm sorry, I'm 6 years old, so I tend to talk at this level. There's a PCIe bus which connects the CPU, the memory, and the various I/O cards. If you extend that outside of the server, then in theory, you've got PCI bus speeds connecting whatever's on the end of it into the server. So hook up a disk array to it. Hook up an IntelliFlash array, an InfiniFlash array. Can you imagine an Accenture running piece of software based on flash storage, terabytes of the stuff, tens of terabytes of the stuff that logically is inside the server's memory address space? When an application in a server makes a request for I/O, it goes through a disk I/O-based code stack. It takes an appreciable time to transfer that I/O stack. When a running application accesses memory, it just does a memory address. So it says, said looking there, it doesn't go through the disk I/O stack. If you could put the storage inside the server's memory address space, you don't need to go through the disk I/O stack to see stuff in it. You can fetch data from it, you can write data to it as if it's a simple memory transfer. I think it was David Flynn of Fusion.io, one of the co-founders of Fusion.io, who first came up with this idea. And well, here he's doing primary gravity because the idea didn't pan out. It was too early. These things, these NVMe, crosspoint, storage, memory, the vast expansion of NAND capacity with 3D chips, the use of TLC, say to me that the server storage area is undergoing a radical change. And Supermicro's driving that, but the others aren't going to be far behind. Dell and HP and Lenovo, Huawei, they all know what's coming. They all know they can't afford to be left behind. And this side of things is relatively simple to me. A piece of hardware is a piece of hardware and has its characteristics. Software-defined storage, on the other hand, this is so hard to understand. Used to be simple. 2000, Datacore gets founded, has a piece of software that virtualizes SANs, does what, in principle, what NetApp or EMC or anybody else's SAN does, but does it by running on PCs and aggregating the disk arrays in the PCs to work across them. It was the first virtual SAN. 10,000 customers, 10 generations of software, but it's a narrow band sort of offering in market terms. It's SMB. I mean, it has a great amount of functionality, but the people you've had on stage here are not Datacore users. I mean, I don't mean that because, of course, they're not. They're your competitors, but they're different sorts of companies. And we've seen blue chip, top global companies here using Accenture storage, which is software only, like Datacore. And that, for me, I mean, as a journalist, I want to be able to write stuff simply. So if I can understand it, then other people can understand it. I can understand a marketing droid for a hardware storage company putting on a software-defined hat. I mean, what better way to pull your competitor's teeth than to put on a software invisibility cloak so your hardware disappears behind it, and then you whitter on about control planes and data planes. I'm sorry, I'm a Brit. I tend to be a little bit rude about some of these, so just excuse me. So that's one thing of software-defined. My thought is that software-defined storage primarily should be software-only storage. If it's not software-only storage, it's hardware-defined and you're locked in. So for NetApp, for example, to say that ONTAP is software-defined, yeah, right. So I can get my HP hardware and run ONTAP on it? Rubbish. Anybody who says that something that's hardware-defined is software-defined is talking marketing claptrap and should be executed on the spot. More Brit rudeness, I'm sorry.
I love you.
Having said that, the ideas of separating a control plane and a data plane seem to me to be extraordinarily powerful. Now, let's count software-defined storage. There's the Hadoop distributions. That's software-defined storage. There's Pernix data, EXI caching. That's software-defined storage. There's Datacore and Nexenta, which is general software-defined storage. There's Atlantis. We'll use RAM acceleration to speed VDI and to speed other VMs. That's software-defined storage. There's analytics. That's software-defined storage. There are so many different breeds of this stuff that for me, to call it all software-defined storage and have Gartner and other analysts say software-defined storage is going to grow like crazy, it's like saying petrol-driven vehicles are going to grow like crazy. What does that tell me about what motorbikes are going to do? What's going to happen with panel trucks? What intercontinental trailer tractors are going to be doing? What sedan cars are going to be doing? What sports utility vehicles are going to be doing? They're not the same category. Now, from outside, it might look as though it's all software-defined storage, and if you're a struggling object storage supplier like Scality, say, or somebody else, then it makes sense to put on a software-defined invisibility cloak again, so you don't have to start selling hard-to-define object storage to people. You're selling another better NAS, or you're selling an S3 interface. It's software-defined. We can take advantage of that. How much longer have I got? I can
Let's wrap it up in the next 5 minutes.
Wrap it up, okay.
Yeah.
What are the effects of all this on the mainstream storage array vendors? Realization number one. Primary data storage is not going to remain with the mainstream disk array vendors' products. It's going to go to flash. They either realize this and work with it, or they don't realize it and they're toast. Secondary data, I'm being very broad in my definitions here. Right? Secondary data, everything that isn't mission critical, is probably going to stay on disk drive arrays for a long time, but it needs to be cheap and deep. Why on earth should CIOs pay for a storage array that's built and defined, and designed and maintained and supported for storing primary data when all they're storing on it is secondary data? The stuff that Nexenta runs on with Supermicro servers is functionally exactly the same as a NetApp, an EMC, an HP, or whatever mainstream storage array. Why on earth should CIOs pay a bezel tax? Because that's all the damn difference there is between these things. Once they start asking a question like that, to which the answer is, to my mind, blindingly obvious, they shouldn't, then when depreciation periods, leases and maintenance periods come to an end, they'll start talking, they'll start thinking about, we should move. Now, the mainstream vendors have got great warm blanket. You can trust them. And this is real, this is valued. It's really important for primary data that your array doesn't fall over. But for secondary data, it's not quite so important. And if Nexenta class software on Supermicro class hardware comes with enterprise class support, with high availability and that sort of thing, and it's cheap and it's just as functional, then billions of dollars of installed storage array value are poised to hit the street and go to smaller suppliers. It is, I've got to wrap up, haven't I?
2 minutes.
In closing,
You're the best.
that's the symbol, right?
No, it's awesome. This is great.
The storage market is a jungle. There are all these packs of different suppliers of different types, the poppies, the sleek hounds, the wolves, sleepy old sheepdogs, dying old hounds on their feet and so on. They're all rushing around or not. And it's a real jungle out there. But there's the king of the jungle. It's Tarzan Manor.
You're the best. Thank you so much. I'll tell you something. I met Chris about in the last 2 years, like 24 months ago. When I met him, we're talking about, I meet a lot of journalists and media and so on. Have you ever seen a journalist or a staff from media, or a reporter, with this much knowledge in the industry? I really mean this. You are a class act. You're awesome. Seriously, thank you for coming all the way from London. I really mean this.
You would make everybody feel like Superman.
No, seriously. This level of knowledge I don't get from any analyst, any visionary. Honestly, VCs, investors should spend time with you before they make any investment.
My call to action is, my telephone number is such and I'm cheap.
I like it. Cheap is good. Cheap is good. You know what? I wish we had hours with you. I'm sure there are a lot of questions. You're going to be here for a while, right? You're not leaving tonight. You're going to be out there for getting a beer and a glass of wine. I know there are a lot of people who are waiting for this. Thank you so much for spending time, and you've been there the entire day. And thank you for all the mentorship, advice. You're not just a journalist and reporter, but you help vendors as well to find the right way. So thank you so much,
It's
Chris.
an honor.
Yeah, really appreciate it.
Thank you.
Thank you so much. Awesome. Big hands.
Fun.